Lesson 8.2 is on simplifying, multiplying, and dividing rational expressions. So rational expression is a quotient of two polynomials. And remember, a quotient is the answer to a division problem. So we're going to be looking at an algebraic expression over another algebraic expression. And we've seen several of those already. We saw some in some review skill warm-ups. However, the ones that we're going to be looking at today have addition and subtraction in addition to multiplication. So when we simplify a rational expression, what we need to do is factor. So when I'm looking at the denominator of my first example, to factor it, it's the AC method. So I'm thinking about 3 times negative 4. So what multiplies to negative 12 and adds to the coefficient of my middle term, which is 1. The numbers that immediately come to mind are 3 and 4. So a positive 4 times a negative 3 will work in both those cases. So remember, you have to factor by grouping when the coefficient of your x squared term is not 1. So I'm going to show off my work in the denominator to kind of keep all of my original problem together. So I'm going to rewrite the 1 as 4x minus 3x. And then I'm going to factor by grouping. So my first two terms I can factor out an x. And for my second two terms, I'm going to factor out a negative 1. Sorry, I ran out of room on that one. So then the 3x plus 4, remember, is my like term, or my greatest common factor. So I'm going to factor out the 3x plus 4, leaving me with an x minus 1. So if you notice, I have a 3x plus 4 in my numerator and a 3x plus 4 in my denominator. So I'm going to cancel those terms. You have to have it factored before you can cancel, because you can only cancel when it's a product versus addition like we had to start with. So because my x minus 1 is in the denominator, it needs to stay in the denominator, which means when I divide my 3x plus 4 by itself, I get 1. So I have a numerator of 1. All right, we'll look at one more example like that. This time in the denominator, we have the t-table method. So what multiplies to 6 and adds to 7. In my numerator, I see a common factor of x, but because of the way that I know it's going to factor in the denominator, I'm not going to have a minus x. So I'm actually going to factor out a negative x from my numerator. And then I'm going to switch the two terms around. So I'm thinking of this as a negative x squared plus 6x instead. So I'm left with x minus 6 after I factor out that negative x. And then in the denominator, what multiplies to a positive 6 and adds to negative 7 is minus 1 minus 6. So again, I've got my x minus 6's that cancel, leaving me with negative x over x minus 1. All right, so multiplying is the same concept. You want to factor so that you can cancel anything that cancels before you multiply. So I'm noticing in the denominator of my first term, I've got a common factor of 4. And in the denominator of my second term, that is a difference of squares, so that factors to x minus 3, x plus 3. So then when I can cancel my x minus 3's, and I can cancel my x plus 5's. Again, in the numerator, I've got a 1. You can leave it factored in the denominator, or you can go ahead and distribute if you prefer. So those are two acceptable answers. We'll take a look at one more like that. Again, in my first denominator, I'm noticing a greatest common factor of 3. In my numerator, I don't see any factoring. In my second numerator, I see a greatest common factor of 6. And in the denominator, I have another difference of squares. So then I start canceling. I cancel my x plus 1's, and I can cancel my x plus 2's. I also have 6 divided by 3. 6 divided by 3 gives me a 2 in the numerator over the x minus 1 that's left in the denominator. Last example, we've got some dividing. Remember, dividing is just multiplying by the reciprocal. So the first thing I'm going to do is rewrite my problem and flip the second fraction and change it to multiplication. And then it's exactly like the same questions we just saw. So I'm going to factor. In my first numerator, I can factor out an x squared. In the denominator, that's the t-chart, what multiplies to 3 and adds to negative 4. So we've got a negative 1 and a negative 3. In my second numerator, I've got a difference of squares. And in my denominator, I've got a GCF of x squared as well. Alright, so what I notice is that in my first numerator I've got x squared minus 9, which is a difference of squares, so I can keep factoring. And in my second denominator I now have a t-chart, so I can keep factoring that as well. However, I also notice that I've got my x squareds, so I'm going to cancel those right away just to simplify things a little bit as I continue to factor. And then in the denominator, what multiplies to 8 and adds to 2 multiplies to negative 8 and adds to positive 2, negative 2, and positive 4. So then I'm going to continue canceling. I see an x plus 4 in the numerator and denominator. And I see an x minus 3 in the numerator and denominator. And all of the other terms I see are prime. So I'm going to go ahead and distribute these back out as I multiply. So the x times the x, negative 4x plus 3x is negative x, 3 times negative 4. And then in the denominator, x times x, negative 2x minus x, and negative 1 times negative 2. All right, we'll take a look at one last example. So this time I'm going to start factoring as I flip. So I notice in my first numerator, I have a t-chart, what multiplies to 3 and adds to 4. And in my denominator, I've got a difference of squares. Now remember, I'm multiplying by the reciprocal. So this becomes my numerator, and this becomes my denominator. But I'm going to factor as I flip it. So now I'm looking at what multiplies to 8 and adds to 6. So remember, this came here. And then what multiplies to negative 3 and adds to 2. And this flipped. So I multiplied by the reciprocal as I factored, just to save myself a little bit of time. So now I'm going to start canceling. I have an x minus 2 that cancels. And that is all that I see. So then this one, in the numerator, I'm going to start multiplying back out. Here, I've got x squared plus 4x plus x plus 4. And that will still be multiplied by the x minus 4. And then in my denominator, I'm going to go ahead and leave my x plus 2, and I'll distribute over here my x squared, 3 minus x, and then distribute one more time. So we've got x cubed minus 4x squared. Now I'm going to distribute my 5x, so I've got plus 5x squared minus 20x. And then distributing the 4 plus 4x minus 16. In the denominator, I'm going to distribute my x, so I have x cubed plus 2x squared minus 3x. And then distributing my 2 plus 2x squared plus 4x minus 6. And finally, I'm going to combine my like terms. So in the numerator, I've got x cubed plus x squared minus 16x minus 16. And in the denominator, I have x cubed plus 4x squared plus x minus 6.